students in class 8 science chapter 6 combustion and flame, and in this video we are going to discuss how do we control fire, types of combustion and the history of matchstick. Let us see one by one. First, how do we control fire? As in the previous video we have discussed what are the essential things or conditions for a fire or for a combustion. These are fuel, air to supply oxygen, and heat to raise the temperature of the fuel more than the ignition temperature. Okay, these are the three essential requirements for fire. Fire can be controlled by removing one or more of these requirements. Like fire brigade pours water on the fire, then what occurs? Water cools the combustible material so that its temperature is brought below its ignition temperature. This prevents the fire from spreading. Water vapors also surround the combustible material, helping in cutting off the supply of air. So the fire is extinguished. The job of fire extinguisher is to cut off the supply of air or to bring down the temperature of the fuel or both. Notice that fuel in most cases cannot be eliminated. For instance, if a building catches fire, the whole building is the fuel and we can't remove it. That's why we have to control supply of air and we have to bring down the temperature of the fuel below its ignition temperature. In that way, we can control fire. Now, fire extinguisher. The most common fire extinguisher is water. But water works only when things like wood and paper are on fire. If electrical equipment is on fire, water may conduct electricity and harm those trying to douse the fire. Douse means extinguish the fire. Water is also not suitable for fires involving oil and petrol because water is heavier than oil. So it sinks below the oil and oil keeps burning on the top. Clear? That's why in two situations, that is if fire is on electrical equipment or fire involving oil and petrol, water will not work. For fires involving electrical equipment and inflammable materials like petrol, carbon dioxide is the best extinguisher. Okay, carbon dioxide being heavier than oxygen covers the fire like a blanket. Since the contact between the fuel and oxygen is cut off, the fire is controlled. The added advantage of CO2 is that in most cases it does not harm the electrical equipment. CO2 can be stored at high pressure as a liquid in cylinders, and when released from the cylinder, CO2 expands enormously in volume and cools down. So it not only forms a blanket around the fire, it also brings down the temperature of the fuel. That's why it is an excellent fire extinguisher. Another way to get carbon dioxide is to release a lot of dry powder of chemicals like sodium bicarbonate, that is also known as the baking soda, or potassium bicarbonate. Near the fire, these chemicals give off carbon dioxide. Okay, and I think you have also seen such type of instruments, equipments at various places, like in the railway station, at bus stand, even in the school. You can see these type of fire extinguisher in a chemistry lab, outside of the computer lab. Is it clear? Types of combustion. Combustion can be classified into three types, mainly rapid combustion, spontaneous combustion, and explosion. And from the diagram you can see, and you can also identify this. What is this? This is the LPG stove. It is burning of LPG. This is rapid combustion. This is spontaneous combustion. And this one is explosion. Firecrackers are there. What is rapid combustion? Combustion in which substance burns rapidly and produces heat and light with the help of external heat. For example, burning of LPG. Spontaneous combustion. Combustion in which a substance burns spontaneously and produces heat and light without the help of external heat. For example, phosphorus burns spontaneously at room temperature. Explosion. Combustion in which a substance burns suddenly and produces heat, light and sound with the help of heat or pressure. It is called explosion. For example, explosion of crackers on applying heat or pressure. Now again, you can say these different types of combustion, that is rapid combustion, spontaneous combustion and explosion. Example of this, we can say matchstick near stove or burning of LPG, and this is very fast. Spontaneous combustion is on its own. Example, coal dust, that is fire in coal dust in coal mines. Even forest fire is also the example of spontaneous combustion. Explosion. Combustion causes large amount of heat, light and sound, and examples are firecrackers. We can differentiate rapid and spontaneous combustion. See what are the differences between these two types of combustion. Rapid combustion is initiated once. We have to start once. Okay. While spontaneous combustion takes place by itself. In rapid combustion, external heat is required to start, while in this case, no external heat is required. In rapid combustion, large amount of heat and light is evolved in a short time, while in this, small amount of heat and light is evolved. Examples are burning of domestic cooking gas in a gas burner. And in this case, burning of white phosphorus on its own when kept exposed in air for some time. Now we'll discuss the history of the matchstick, and all of you are familiar with this matchbox and matchstick. Okay, and its history is very old. More than 5,000 years ago, small pieces of pine wood dipped in sulfur were used as matchstick in ancient Egypt. The modern safety match was developed only about 200 years ago, and a mixture of antimony trisulfide, potassium chlorate, and white phosphorus with some glue and starch was applied on the head of a match made of suitable wood, and when struck against a rough surface, okay, white phosphorus got ignited due to the heat of friction, and this started the combustion of the match. Okay. However, white phosphorus proved to be dangerous both for the workers involved in the manufacturing of matches and for the users. These days, the head of the safety match contains only antimony trisulfide and potassium chlorate. The rubbing surface has powdered glass and a little red phosphorus, which is much less dangerous. When the match is struck against the rubbing surface, some red phosphorus gets converted into white phosphorus. This immediately reacts with potassium chlorate in the matchstick head to produce enough heat to ignite antimony trisulfide and start the combustion. Okay, students? Thank you.